Welcome back, children. Today we have to discuss the new topic, that is applications of determinants and matrices. So in this section we have to discuss how to solve system of linear equations using matrix method. Already in 10th standard you studied system of linear equations in two variables, and you know how to solve it using substitution method, elimination method and cross multiplication method. Here we have to solve these equations using matrix method. So first we have to discuss what is consistent and inconsistent system. So consistent means, you already know all these things. Consistent means a system of equations is said to be consistent if its solution exists. If no solution exists means that system of equations are inconsistent. Now the next is solution of system of linear equations using inverse of a matrix. That is, this method is known as matrix method. So before that we have three equations, linear equations in three variables, a1x plus b1y plus c1z is equal to d1, and a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Then we write these equations as matrices. So look here how to write. First I write a matrix, write the coefficients only, that is coefficient of x, y and z. So in the first row we have a1, then b1, then c1, next row a2, b2, c2, then last row a3, b3, c3. 3 by 3 matrix. Then next is a column matrix. What's a column matrix? A matrix having only one column. So in the column matrix we write the variables x, y and z. Now the right hand side again a column matrix, write the numbers, these constants d1, d2 and d3. So look here, a 3 by 3 matrix and the order of column matrix is 3 by 1. So we can multiply, the answer will be a 3 by 1 matrix. So look here, it is a column matrix 3 by 1 matrix. Now we express this matrix as capital A and this as capital X equal to capital B. So capital A means the matrix where A is equal to matrix A1, B1, C1, A2, B2, C2, A3, B3, C3, and X is equal to the column matrix X, Y, Z, and B is equal to the matrix D1, D2 and D3. So we have an equation Ax is equal to B. Here A, it's a matrix, all these will be numbers. Here also x is the variable part. So we have to find x, y, z. So what we do is pre-multiplying this equation by A inverse. So the first case is, we have two different cases. Case 1, if determinant A not equal to 0. That is, A is non-singular. A is non-singular. If A is non-singular, we multiply this equation Ax is equal to B, pre-multiplying by A inverse. Pre-multiplying by A inverse. So when we multiply A inverse A into X, three matrices are there, we can combine A inverse into A by the associative property of matrices. So A inverse into A becomes I. So I into X is equal to A inverse into B, or I into X is X itself, A inverse into B. So this is the way we can find x. X means it's a column matrix. There are three unknowns are there, small x, small y and small z. So that x is equal to, that matrix is equal to A inverse of matrix A into B. So inverse of matrix A into B means, inverse exists means determinant A cannot be 0. So if determinant A is equal to 0, what happened? So we have another case. So look this diagram, children. Okay, so we have this equation Ax is equal to B. So if determinant A, you have to find determinant A. If determinant A not equal to 0, you will get the value. Definitely there is unique solution. You will get one value for x, y and z. Okay. If determinant A equal to 0, the next step is you have to find adjoint of A. Then if adjoint of A not equal to 0, multiply adjoint of A with B. If that is not equal to 0, then you can conclude no solution. Children, do you remember in 10th standard you studied? There are 3 types of system of equations, that is parallel lines, intersecting lines, coincident lines. That means there you studied the ratio. If A1 by A2, right? A1 by A2 and B1 by B2 and C1 by C2. If these two not equal, then you can conclude unique solution, that is lines will intersect. If all these are equal, then there are infinitely many solutions or lines coincide. If these two equal but last one not equal, then lines are parallel, that means no solution. Here also that 3 cases. So if determinant A not equal to 0, unique solution you will get. If determinant A is equal to 0, you have to calculate adjoint of A. Then that is not equal to 0 means find adjoint of A into B. If that is not equal to 0, you can conclude no solution. If that is equal to 0, adjoint of A into B equal to 0 means infinitely many solution. Then here, if adjoint of A is 0, you have to compare these ratios A1 by A2, D1 by D2, A1 by A3, D1 by D3. If these ratios are equal, that is if verify this, if both verified, you have to write infinitely many solutions. But if these not verified, that means no solution. This part is not given in the textbook. We have problems. In the problems we have always determinant A not equal to 0, that case only. And if determinant A equal to 0, we find adjoint of A, then into B. If not equal to 0, no solution. That much case is given in the textbook. Okay. So I hope all of you understood this section. Then we can do problems. So in the problems, the first one is check the consistency. First question. Examine the consistency of the system. First equation, x plus 2y is equal to 2 and 2x plus 3y is equal to 3. So here we have 2 equations. We have to check. The question is examine the consistency. So you have to write whether the system is consistent or inconsistent. That much only. So we write this as matrices. So you have to write the coefficient. Coefficient of x is 1, y is 2, that is one matrix. The next row 2 and 3. So this is one matrix. Then variables always write as column matrix. Then right hand side also column matrix. So this is Ax is equal to B, where A is equal to 2 by 2 matrix 1, 2, 2, 3 and x is equal to column matrix x comma xy and B is equal to 2, 3. Then so Ax is equal to B. Now is the system is consistent. So what you have to check? you have to find determinant A. Determinant A is equal to determinant 1, 2, 2, 3. So 3 minus 4 is equal to minus 1, not equal to 0. So if determinant A not equal to 0, you can write unique solution exists. So the system is system of equations is consistent. Why the system is consistent? Consistent means if solution exists, that is known as consistent. So here determinant A not equal to 0 means unique solution exists. That is the condition. So the system is consistent. Clear this one? Now the second question. X plus 3y is equal to 5 and 2x plus 6y is equal to 8. Here also we have two equations. So we write this as 1, 3, 2, 6, one matrix, then column matrix x, y, right hand side 5, 8. Ax is equal to b. A is the first matrix, x is this column matrix, b is this column matrix. Then first we find determinant A. Determinant 1, 3, 2, 6. What is 1, 3, 2, 6? 6 minus 6 is 0. So determinant A is 0. So unique solution cannot exist. So the next step is you have to find adjoint of A. Adjoint of A is equal to, it's a 2 by 2 matrix. So just interchange 1 and 6, change the sign of 3 and 2. This is adjoint of A. Now find what is adjoint of A into B. Adjoint of A into B, that is 6 minus 3 minus 2, 1 into column matrix 5, 8. So the order of the first matrix is 2 by 2, second is 2 by 1. So answer will be a 2 by 1 matrix, that is a column matrix. Multiply first row into first column. 6 into 5, 6 into 5 minus 3 into 8. Then minus 2 into 5 plus 1 into 8. So that's equal to 30 minus 24, that's equal to 6 and minus 2. Is this matrix a 0 matrix? No, this is not equal to 0. That is adjoint of A into B is not equal to 0. So what is the conclusion? System is no solution, that is the condition. No solution exists. That means system is inconsistent. System is inconsistent. Okay, once again you check. First you have to find determinant A. If that's equal to 0, find adjoint of A, and adjoint of A into B. If that is not equal to 0, system is inconsistent. Now one more question. Question number 3. X plus y plus z is equal to 1. 2x plus 3y So this is the given system of equations. So we write as matrices 1, 1, 1, only coefficients. Coefficients of x is a, y is a, z is 2a as a matrix. Then column matrix x, y, z. Here we have 3 unknowns x, y, z. Then column matrix 1, 2, 4. So A into X is equal to B, where A is the first matrix. A is equal to matrix 1, 1, 1, 2, 3, 2, A, 2A, and B is equal to 1, 2, 4, and X is equal to X, Y, Z. So Ax is equal to B. The next step is we have to find determinant A. Determinant A means determinant 1, 1, 1, 2, 3, 2, A, 2A. So that's equal to 1 into, delete the row and column, 3 into 2A, that is 6A minus 2A. Then minus 1 into 4A minus 2A plus 1 into 2A minus 3A. So 4A minus 2A minus A, that is A. So we get A. Then is A 0 or not equal to 0? If A equal to 0, look, if A is equal to 0, look the last equation. If A is 0, this part 0, 0, 0. So we get 0 is equal to 4. Is that statement correct? No. So we have to, so we can say that this A cannot be 0. That is determinant A cannot be 0. So what is the conclusion? System is consistent. That is unique solution exists. System is consistent. So I hope all of you understood this section.